going to look at one of the harder questions, the extra questions. So question 7. Okay, so it says we've got a linear equation and we've got a quadratic. K is a non-constant 0. So for part A, we're going to show that this quadratic is equal to 0. Well, what do? I take my linear, which is y minus 2x equals 8. I'm going to restate it so it's in terms of y or x. Now, I think the easiest way to do this is to do this in terms of y. Right, now I've got my quadratic, which is x squared plus 2k times y plus 4k equals 0. Right, now, what I'm going to do, I'm going to take my restated value of y, which is 8 plus 2x, and substitute that into my quadratic. So now I've got x squared plus 2k times 8, which is 16k. And then I've got 2k times 2x, which is 4kx. And I've got 4k on the end. Now, all we're going to do is collect together our k's. And what we're looking for is x squared plus 4kx, which is my middle term, 4kx plus 20k, which is 16 plus 4, 20k, and that's to 0. So first part taken care of. Now part B. Given that that quadratic is 0 and has equal roots, find the value of k. Right, so now we know if it has equal roots, the discriminant is 0. So now let's look at our quadratic. A is 1, B is 4k, and C is 20k. So let's put in the discriminant. B squared minus 4ac has to equal 0. So that means that 4k squared minus 4 times 1 times 20k has to equal 0. And if we expand that out, 60k squared minus 4 times 1 times 20k is going to give me minus 80k equals 0. So now we've got to factorize this to find the solutions. Well, 16 comes out of both, k comes out of both, so we've got a common factor. And what are we left with? 16k times k to get 16k squared minus 16 times, well, 5. 16k times 5 gives me a minus 80k. Right, so what are my solutions? My solutions then are going to be minus 5. So what have we got? So there, that means that my k, to solve this equation, k is going to be 0, which is, remember, whenever we've got a solution outside the bracket here, 0 times anything is 0. So k equals 0 is the solution. And inside, I've got 5. But remember the question said that k was a non-zero constant. So that means that it can't be 0. It has to be 5. And that is the only solution. Right. Okay. So that means that B takes care of it. Now we're going to get to C. C. For the value of k found in part B, so that was that k was equal to 5, solve the simultaneous equations. Okay. So now we'll go back and restate our equation again. So y equals 2x plus 8, and we have that x squared plus 2ky. Well, we know that 2k is 10, so that's 10y. And we had plus 4k, but again, we know what that is, so that's plus 20 equals 0. Now it's just a simple simultaneous equation. So we do the same thing, x squared plus 10 times, and we'll substitute our value of y, which is 2x plus 8. And then we'll add our 20 and that equals 0. Expand it out. X squared plus 10 times 2x, which is 20x, plus 8 times 10, which is 80, plus 20 equals 0. So that means our quadratic is x squared plus 20x plus 100 0. Okay, so now we're going to factorize this and work out what our solutions are. Well, I need a number that adds up to 20 and gives me 100 when I multiply it. So my sum and product, easy, you know that. X plus 10 times x plus 10 equals 0. So x equals minus 10. Now, it's important. Remember at the beginning, it says it has equal roots. So what do we have? One single root. Okay, now, if x is minus 10, we still need a y value. And we said that y was equal to 2x plus 8, which is equal to 2 times minus 10 minus 20 plus 8. So y is minus 12. And that's part C taken care of. Hopefully that makes sense.